Hello everyone. This lecture is about the algorithms again. So you won't see me importing NumPy or Pandas or Matplotlib. So there's no data sciencey coding in this lecture. And you may wonder, why do we have to learn so much Python coding? There are good reasons. Even though, I remember when I first started to use Python to do data science, and when I learned the NumPy and Matplotlib, the data frames, I really feel the same thing as you may feel. That's super powerful, and we can process the data really efficiently and they can help us minimize the number of the lines of the code we have to write. And then when you are going deeper, and then you will find that from time to time, you have to do the things by yourself. There's no really easy way that you can do that with a NumPy, with just a few lines of code, and instead you have to write your own code to get accomplish a certain task. For example, earlier today, and then I talked to uh, a senior graduate student also from this program, and he told me when he tried to do a open CV coding, and he has to create a mask to filter out some of the colors so that the video processing only keep a certain color. And this color could be a little bit darker, or it could be a little bit brighter. And then, how can this be done? And he told me he had to uh, code a grid search by himself so that he can figure out the parameters for a mask to mask out the other unrelated color and only keep the color he's interested in. He had to do that by himself. And for now, and when you are manipulating a relatively good data set, and you don't feel like you need the Python coding too much. But later, when you start to do some harder work, or the data set is really dirty and messy, and then you will feel like you are going to do some Python coding by yourself. Okay, so I'm using a few problems today to show you why the basic Pythonic coding is still important even though you're doing data science. Okay, so let's see the first question. The first question is called three sum, and remember we have already done the two sum, right? And then for the three sum, we are grabbing three values from a list, and then the goal is if we add those three values, and then the result should be a zero. Okay, so say if we have this list, and then how do we get three values so that we have the sum to be a zero? The first thing I see is the -1, 0, and 1. You add them together, and then you have a 0. So what else? Another one will be the -1, -1, and 2. We add them together, and then we have a 0 again. It seems that this coding problem is super easy, right? No, not really. As we go down and down, you will find this is really a easy but still good coding exercise. I would say if I'm interviewing a data science person, and then I would give this problem as an interview question and say, okay, you have 30 minutes, and then do you understand this problem? And if you understand this problem, okay, here is a whiteboard, and go and write down your solution. And after that, and then, let's talk about the test cases, and let's talk about the time complexity, and then let's see, number one, are you able to code this problem? And number two, are you able to come up with the test cases to make sure that your solution is really correct? And number three, let's talk about the time complexity and see if you understand how to analyze algorithms. Okay, so we are going to see them one by one in this video. So the first thing, let's see. We are the easiest thing we can do is we exhaustively come up with all the combinations of three items from the given list. And then for each of the three combination, we add them together. And if that is a zero, and then tada, we find one of the good combination. Okay, the idea is very simple, and then we just try to come up exhaustively all the possible 3 combinations. So I'm doing for I in nums, and then for j in nums, and for k in nums. And then if 0 equals I plus j plus k, and then I do find a good 3 combination. So I'm putting that into a list to return. So for this list to return, it will contain all the possible 3 combinations of the values from the list, as long as the sum will be a 0. Okay, so if I run this, well, my first question is this solution even correct? And let's see. Well, -4, 2 and 2. And remember, we are doing this on this list. So -4, 2 and 2. Is that really a valid one? Okay. Well, if you say that is a sampling with putting back, and then you may say, okay, that is still a valid one. But if we do not allow putting back, and then the problem is we only have one of the value 2 here. So there's no way that we can grab 1, 2, and then later we grab another 2. So this solution is not even correct. So how do we fix that? So for this type of the iteration, we are using the I, j, or k to visit all the members of the list one by one. And if we can't do this way, we have to do another way. That is, say if we are using the I to visit the -1, and then for the j, we have to start the j as the 0. So say if I is already holding the -1, and then for j or the k, they cannot use that -1 again. Even though there's another -1, so yes, we can use another -1. But for the -1 that we are holding with I, that value cannot be used again. So we have to start from the j here. And since we are starting from the j here, so I is holding -1 and j is holding 0. And how about k? So k, we have to start the k from the 1 and then search from the right side. Okay, so the strategy will be we hold the I value, and then we can only do the search of the j starting from the right side of the I. So j will start from the right side of the I, and then we go forward. And then similarly, if we are holding the j here, and then for the search of the k has to start from the search from the right side again. Okay, so we'll after we decide we have to use this idea, and then the problem will be, okay, we want to use the I, j, and k as indexes instead of as values. Well, and how do we do that? Well, first we have to know the len. Well, len is a function that if you send a list to the len function, and then it will tell you how many items are there. And say here, we know we have 6 items. So if you want to print the count of the items in comma len, and then you will get a 6. This means there are a total of the 6 items in the list. However, if you are counting the indexes, well, and then you will be from 0 to 5. So index 0 is -1, and then the last one, 5, will be 75. So how do you come up with the indexes? So you can do the for I in the range from 0 to the length of the num, and in Python the rule is the start point of the range, which is 0, is included in the range. And then for the last value, which is the length, or 6, that is excluded from the range. So even though we are doing a range from 0 to 6, and considering the endpoint is excluded, so in the range we really have from 0 to 5. And again, that is basic Python, and you have to remember that. Okay, and then after that, well, we know I, j, and k will be used as the indexes. So I'm gonna start doing the search using the I, and then I will start from the very beginning, but I have to leave the space for j and k at the very last items. Okay, so I'm starting the search from 0, and then, well, you may say, okay, I should do 0, comma, the length minus 2, but you don't have to. Well, if you only do the range with one value, and then that value is the endpoint and the start point, since I didn't specify, that will be starting from 0. Okay, so for this part, I'm gonna start the range, the search for the I starting from the index 0, but I'm gonna end on before the second last item. Well, and then the second last item I will reserve that slot for J, and then for the last item I'm reserving that for K. So I'm starting from the index 0, which is the very beginning, and then I'm ending the search with the I on the third last item. So on the right side, there will still be two items for J and K. Okay, so similarly for J, the search space will be I plus 1, which is one item on the right side of the I, and then going all the way to the end, and then go one step back, because the last item will be visited by K anyhow. And then for the K, it will start from the right side of the J and then go all the way to the end of the list. Okay, so by using this way to do the searches, and then we guarantee that we won't have the problem similar to this, because we only have one two value, and then we can't grab two twos because we don't have two twos. Okay, so well, for this one, and then if we are trying the test cases, the -1, 0, and 1, and 99, 88, and 77, so those three values would be a good answer. And then if I shuffle the values a little bit, and then I can see, okay, well, that is still a good answer, right? So well, this solution is almost finished, but still there are some minor problems. So let's see this one. So for this one, for this test case, we have two -1s, a 0, a 1, and then we have a 2, and then -4. Okay, so if we run this algorithm, we see a small problem. The problem is, well, for this one, -1, 2, and -1, that's good, right? That is a valid answer. And how about those two? So -1, 0, and 1, so -1, 0, and 1, that's good. And then 0, 1, and -1, that is 0, 1, and -1. So that's also a good answer. But however, they're the same thing, right? We are coming up with those two answers of the same set of the numbers, because we have two -1s. So well, there are two duplicated entries. We want to get rid of one of them. So how can we do that? So here is the trick we have to explore a little bit before we can come up with a solution. So say we have the A as the first one, the -1, 0, and 1, and B as the 0, 1, and -1. So the first question I want to ask is, are they the same? Well, if I want to check the value of the A equals B, I got a false. So in Python, those two lists are not considered to be the same thing. That's a problem. So if they're not exactly the same thing from Python, and then how do we kill them? How do we identify them as the duplicated entries? So well, I have an idea. The idea is, how about we sort them? So A sorted and B sort. So we are sorting A and B in place, and then okay, that's good. So now A and B are really the same thing now, right? Okay, so well, following this idea, well, it seemed that for all the possible solutions I come up with this algorithm, the step missing will be, I want to sort them, and after sorting them, and I can remove the duplicated entries, right? So I'm going to start from here. So those will be the output I got from this version of the code. So for this version of the code, the first half, well, that's good. We just have the second half missing. That is how we can get rid of the duplicated entries. So how do we do that? So the first thing we want to, for each of the elements in the unsorted solution, we want to put them into the tuples, and then I want to put the tuples into a set. Well, remember what it said. Well, a set is a dictionary, but we only have keys but no values. Well, that means for a set, there is also a hash table behind the scene, right? Okay, and then after we have a set, and then all the and then well, taken this set, and then we have all the members in the set are the three member tuples. Okay, and then for each of the three member tuple, I want to get them sorted and then put them back. So I have a sorted tuples, and then I want to grab all the items of the tuples in this set. I want to sort them and then put them into a sorted tuples. So after that, I got this word. So they are sorted. Okay, and then after doing the sorting, you see the potential. This one and this one. Now they are considered to be exactly the same in Python. So well, moving on, we only have to figure out a way that we can get rid of the duplicated, sorted 3-item tuple or 3-item list, right? And how do we do that? And the answer is, how about we use the sets? Because for the sets, they will filter out the duplicated entries for us. Well, similar to the dictionary. For dictionaries, we cannot have duplicated keys, right? For the set, that's the same thing. So if we are sending the 2 of this tuple to the set, and then the set will only keep one of them. So we are making use of this nice feature of the set in Python to get rid of the duplicated entries. So we send each of the sorted 3-item tuple into a set. And then after we have the set, and then we put them back into a list of 3-item sublists. So eventually we got this. Okay, and then and you see, well, when I'm solving this problem, well, I didn't jump in and then show you, okay, this is the final solution. Well, I didn't solve it this way. Again, well, I started a small piece, and then I see the problem, and then I open another code block, try to attack this problem, and after doing that, and then start and using that part as a start point, and then let me figure out how do I go one step further to solve this problem. And eventually you see I got like a total of almost 10 code blocks before I come up with this solution. Okay, well, this is a common way that when you write a function. So this is a function. Well, to make sure that this function is good, well, you don't have to just jump in to the function definition and then define everything in the function. Well, sometimes, well, if the problem is hard or the solution could be tricky, well, you may start this way. You do one code block, solve a part of the problem, and then you move on to the next code block and solve another part of the problem. And eventually, using this step-by-step pipeline, you got this problem solved, and then you put the code into a function definition. Okay, so this is my solution. For this part, I'm just doing the searches with I, J, and K, and after that, I'm using the feature of the set to filter out the duplicated entries. Okay, so eventually I got this solved, and I'm reasonably happy with this solution. Well, if I'm interviewing someone for a data science job, and as I said, this might be a really good question. Why? Because number one, it's not so hard, but number two, to get the solution really correct, that's not easy, right? As you see, well, the first trick part will be the search. You have to do the search correctly in order to get the possible candidates. And after you get the possible candidates, and then you have to do this part to filter out the duplicated entries. So this problem look like not so hard at the first glance, making it correct is not easy. Well, and then the last part, let's talk about the time complexity. Well, you see, well, this is a search for the if the length of the list is n, and then for the search of the I, it will go for n minus 2 rounds, and for the j, n minus 2 rounds, and for the k, n minus 2 rounds. So, well, that will be a O n cube algorithm. So anyhow, well, if you're able to come up with this O n cube solution, well, this is not the perfect solution yet, but coming up with this version of solution is not easy. Okay, so I'm going to stop this video here, and in the next video, I'm going to show you another slightly better solution.